So far, we have learned how to find significant figures. Significant figures are obtained from a measured number, and we learned when zeros within that measured number are significant and when they are not. But why are we counting the number of significant figures? The reason why we are counting the number of significant figures is because the measurement that we obtain are data points, and we normally manipulate data. We multiply, divide, add, subtract, all that and other functions as well, and we do all that so that we refine the data. And that's where rules for multiplication, division, as well as addition and subtraction show up. There are other rules for other operations as well, such as logarithms and exponents, but we will not address that in this course. But we will address the rules for multiplication, division, and addition, subtraction. First, here in this video, we will look at the rules for multiplication and division. And let's have a look. So here we have these three numbers. Now the rules for multiplication and division are the same, while there is another rule for addition and subtraction. So here we have these three numbers: 4.2 times 10 to the third, 15.94, and divided by 2.255 times 10 to the 4. All these three are measured numbers. Perhaps there is a centimeter or a kilometer or a liter or some other unit associated. We are not showing that. And when we multiply and divide them out, each one, we will notice, has different number of significant figures. The first one given to us here in scientific notation has two significant figures. This number here has 4 significant figures, and this number here has 4 significant figures. How many significant figures should we have in our calculated answer? So take your calculator out and do this operation. When it comes to multiplication and division, it won't matter with the order. You might as well multiply this 2 in the numerator and then divide it by this. Or you might choose to do it by dividing this by this and then multiplying it with this. Regardless, this is what your calculator gives you. Now notice how many digits here are. And since this particular number is a product of many operations performed on measured numbers, this number also has significant figures associated with it. But if we then count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 significant figures. Now that is not possible. Significant figures, the job of significant figures is to give us the is to reflect on the instrumental power. And here we have 2 sig figs, here 4 and here 4. And you may have heard the saying that a chain is only as strong as the weakest link. In these three numbers, the weakest link in terms of significant figures is this number with just 2 sig figs, where our precision is in the 10th place. The more digits we have, the greater the precision we have, we say. Now that means that when our calculator gives us this value, all these digits here do not reflect that precision, because we don't know after this 2 in the hundreds place what could be the next number. This 2 itself is an estimated digit, and we cannot estimate any further. It might as well be 1, it might as well be 9, which would change this digits drastically if we were to actually put it there. So when the calculator gives you this, you have to round it. We learned how to round, and now is the time to round it. How many sig figs will you round it to? You will round it to the number of sig figs in your weakest link, or your least number of sig fig measured number of all the numbers you have, which is 2. So you have to round this to 2 digits, and when you round it correctly, it will become 3.0. So the calculator, even though we call it a scientific calculator, it's a sort of a misnomer, because it's not doing scientific calculation. It's very ironic. It's only called a scientific calculator because of other functions that are not available on other simple calculators like logarithms, exponents, and the trigonometric functions.